Hello, welcome to our channel for probability and statistics. In this video, we will talk about one-tailed test and two-tailed test in hypothesis testing. So in hypothesis testing, if a test of any statistical process where alternative test is one-tailed, such as theta equals theta 0 is null hypothesis H0, and H1 or alternative hypothesis is theta larger than theta 0, or null hypothesis H0 is theta equals theta 0, but alternative hypothesis H1 is theta less than theta 0. So this kind of test is called a one-tailed test. So generally, the critical region for the alternative hypothesis theta larger than theta 0 of the distribution of the test statistic, while the critical region for the alternative hypothesis theta less than theta 0 lies entirely in the left tail. So we either use this one or this one figure to test the one-tailed test. So for example, in the test distribution is normal probability distribution, and significance level is 0.05 for the alpha. So we can find critical region if the test statistic larger than 1.65 in this one-tailed test. So we can say the test is significant because 1.65 represents this shaded area is 0.05 in the probability. So we get the value of the test statistic larger than 1.65, which means the p-value or the test statistic will lift probability to the right with less than 0.05. Also the p-value less than 0.05. So the test is significant. And if in this one-tailed test, H1 is theta less than theta 0, if we get the test statistic is less than minus 1.65, here, for example, then we also say the test is significant because the probability in a normal distribution, if critical value is minus 1.65, then this shaded area is also have probability 0.05. So if we use alpha equals 0.05 in the test, in the hypothesis testing, so we get a negative value less than minus 1.65. So the test will be significant. So the example is for the one-tailed test, like vaccine experiment to test the hypothesis H0 probability 1 of 4 against the one-sided alternative probability 1 of 4, p larger than 1 of 4 in a binomial distribution. So in the end, if we get the test statistic in this region, then we say test is significant, right? If we get otherwise in this region test, the value, for example, we get 1.2 in a normal test, then the test is not significant, and we will hold H0 that p equals 1 of 4, right? And which one you should use? H1 theta larger than theta 0 or H1 theta less than theta 0 in a one-tailed test, because you can also test one of them, right? And this is based on your subject, your experience. So usually it is quite obvious you will test larger than this theta or less than this theta, not both. So this is a one-tailed test. Because there's only one probability that the test statistic will either larger than this one or less than this one, not both. So in this situation, you use a one-tailed test. And for normal distribution, if significant level was defined at 0.05, so the test statistic will be compared with 1.65. So next we will talk about two-tailed tests. So test of any statistical hypothesis where the alternative is two-sided, such as H0, null hypothesis is theta equals theta 1, theta 0. But alternative hypothesis H1 is theta not equal to theta 0. So this kind of test is a two-tailed test. So because both can happen, that test either get a result in this region or in this region. So we do not know before test that the test result will larger than this one, larger than H0, or only one of them. We're not sure. So we just test if it is equal to theta 0 or not. So this kind of test is two-tailed test. So we also define the significant level alpha 0.05. But in two-tailed test, 0.05 have to be divided by 2. So each of these end region in the normal distribution represents 0.025 for the probability. So that's why the critical value is larger than the absolute value of the critical value is larger than in one-tailed test. So here is 1.96. Because 1.96 in a standard normal distribution will leave the probability to the right about 0.025. So if you test and calculate, got the test statistic, for example, get 2.5. So the test will be significant because 2.5 here will leave this area to the right less than 0.025. And this area you have to times 2, multiply by 2. You get the final result less than 0.05. If you got test statistic in this region, not the blue region, in the gray region, then test is not significant at 0.05 alpha level. So example is a two-tailed test was used to test the null hypothesis that mu equals 68 kilograms against two-tailed alternative mu not equal to 68 kilograms in the example of the continuous population of student weights. So you test for the random sample and got statistic. Test the statistic if in the end, in a normal distribution test, you got the value, for example, is minus 2.5. Then this test is significant because minus 2.5 will almost leave about 0.001 probability in this region. It is much less than 0.025. And this region times 2 also much less than 0.05, which is the significant level in this test. So in conclusion, that one-tailed test usually the critical value is less than two-tailed in the same distribution, right? Because two-tailed will leave half of the significance level probability to the right and to the left. So this is half of the significance level. So if a significance level alpha is 0.05, so here is 0.025 for this blue area. So either of these two blue areas represents half of the alpha. That's why we use 1.96. And people usually use 2 because 2 is almost approximately equal to 1.96. So if you got test statistic absolute value larger than 2, so the test is significant in a two-tailed test, because absolute value larger than 2 will either in this blue region or in this blue region, right? So, but in one-tailed test, only one of the probability can take either the test statistic larger than 1.65 or less than minus 1.65. So that's why we use 1.65 for absolute value here, because 1.65 represents 0.05 in the probability leave to the right or leave to the left in a standard normal distribution. So we do not go more detail for calculation of the test statistic, because we will show many different cases in calculating the test statistic in hypothesis testing in later other videos. Thanks for watching.